Okay, to review from yesterday a little bit, we have definite integrals and we have indefinite integrals. So definite integrals when you have the numbers here and you have limits on the left and the right, and when you plug in the top to the integral minus plug in the bottom to the integral, and that gives you the area under the curve. The indefinite integral won't have limits there, so it's basically like just saying like if this is the derivative, what was the original? So it's just saying like go up a level. You don't have to plug anything in. We're not finding area. We're just finding like the equation that is the level above this. So we talked about this yesterday a little bit actually. So what's the derivative of x squared plus 1? 2x. What's the derivative of x squared minus 5? 2x. What's the derivative of x squared plus 1,000? 2x. So then the antiderivative of 2x could be any one of those or a billion other things, and that's why we have to put that plus c. Does he have something here I'm supposed to like fill out, or I didn't watch this video or check it out. Nobody watched the video. It's okay. I gotta make up over it. So we're not gonna do that one in the notes, but let's just do. Let's say that I have f of x equals f prime of x equals 2x, and f of 0 equals 8. Directions here would say find the particular solution. So I'm going to integrate that to get my to find out what f of x is. So what's the integral of 2x? That plus c. So then we know that y equals x squared plus c. And it like really matters on this one because our job now is to find out what c is. So if we forgot to put the plus c here, and then we're trying to find out what c is, you're just kind of stuck. What can I do right now to find out what c is? Well, I got like 3 variables, right? So go ahead, you can show it. Yeah. So you can plug in x and y. So I know 8 equals 0 squared plus c, which means 8 has to equal c, which means I can go back to my equation from above and write it more specifically. I can write it back. So if they ever want you to find out what c is, they have to give you a point to work with so you can plug it in and find out c. And there's a couple more of those in the notes, so we can do a couple more. But questions on what I'm doing there? Alright, there's a bunch of definitions. I'm going to go back to that. No, I guess I can't. What's the integral of e to the x? False. Plus c, yes. Because the derivative of e to the x will e to the x, right? So the integral's got to be e to the x. If you remember when we did the derivative of y equals a to the x, it's been a while, but, and this isn't one of the super common ones. It's 1 over the natural log of a times a to the x.
Yeah, you're right. That's exactly what
Good job, Will. All right, let's see.
So what's the integral? Why am I brain farting right now?
it is.
That's the derivative.
No, that's it.
Oh no, the derivative is a to the x times ln of a. Alright, so it's back. So the integral is 1 over ln of a times a to the x plus c. So, okay, my fault. I got the derivative and integral mixed up. Okay, so number 1, find the general solution of 7 to the x plus c. So we're not finding the particular solutions when we have to find c. The general solution means we just get to leave c in there and not worry about what it is. So my job is to integrate 7 to the x times dx, and I don't have to plug anything in. I can just leave it as the plus. So that's this rule. So your a is 7, so your answer is going to be ln of a times 7 to the x plus c. And I could give you information like x and y so you can find out what c is, but I don't have to. Sometimes you will, sometimes you won't. So there'll be a couple on the gateway that you have to find c. I'd say most of them you won't. But number 2, we're asking for a particular solution, so now we are going to have to find c. So first of all, just kind of think why we're doing it. They gave me f prime, and they're asking me about f. So how do I go from f prime to f? Is integrate, right? So that's why I'm integrating. And then this will allow me to find out what plus c is. It's because I'm a freaking idiot. I keep confusing the derivative. I'm sorry. It should be that. Thank you. Yeah, my bad. Make sure you didn't. Make sure you got this. Thank you. Are we good on 1 then? Did I go 2? My bad. No, you're good. That's my fault. So to go from f prime to f, I got to integrate. So I'm going to integrate e to the x minus 2x squared. Well, what's the integral of e to the x? E to the x. So it's technically plus c, right? But there's going to be a plus c here, and really you just need to put like what's a constant plus a constant? It's just another constant. It doesn't even have to be bigger. It could be smaller. It could be the same. But like there's a c here and a c here, so you don't need to put like plus c plus c plus c. You just put plus c once, and it's understood that it represents like the combination of all the c's. Integral of this would be add 1 to the power, multiply by the reciprocal of the new power. So I would get that. That part okay? Gracious. It's like the freaking point of the problem is the plus c. Yeah, I totally meant to do that. Yeah, exactly. Do students ever believe that when teachers say that? Like, that's such a. I'd rather just be like, yeah, sorry. Okay. So x is 0, y is 4. So I'm plugging in 0 for x. Minus 2/3 times 0 to the 3rd plus c equals 4. See what I'm doing? And then what's e to the 0? Don't say 0. Anything to the 0 power is 1. This stuff is all 0, so you just get 1 plus c equals 4, which means c equals 3. And I'm kind of out of room, but your answer is like rewriting it, but putting this what c is now that you know it. So this would be like plus 3 at the end. So it's like a better version of what we had here, because we can actually find out what c is. Question on those? We got e's in there, which tends to confuse people, and we're doing like a new topic. So, all right. All right. Can you tell me what the integral of 1 over x is? You know it. So first of all, yeah, you're good. You're right. So first of all, those are the same, right? Weirdly, some people will be like, I know how to integrate 1 over x, but I don't know how to integrate x to the negative 1. It's the same thing. But here's what kind of happens if you try to do this one. You can memorize it, but it's kind of nice because you get stuck if you forget it. So a very common thing is students will be like, okay, I'm going to add 1 to the power. And I'm going to multiply by the reciprocal of the new power. If I multiply by the reciprocal of 0, doesn't that 0 end up on the bottom? The reciprocal of 0, I don't know what would be on top really, but the 0 would have to go to the bottom. So then I end up with a 0 below, and I'll end up dividing by 0. Can I divide by 0? I cannot. So if you try to do the regular power rule, where you add 1 to the power and multiply by the reciprocal, you kind of get to here, and then you're like, well, crap, what's the reciprocal of 0? I don't really know, but I'm going to be dividing by 0, and that doesn't work. So it kind of helps you remember that you don't use the power rule in this situation, because you get stuck if you try. And what it comes out to be, and we did this with derivatives, I used to give you like, what's the derivative of ln of x, and you would tell me 1 over x. So now we're just going backwards. The integral of 1 over x is ln of x. The absolute value is there because you cannot take the square, or the ln of a negative number. So it just forces that x to be positive so that we can actually work. So like number 3, I got the integral of 1 minus, and I'm going to rewrite it 5x to the negative first. And I can integrate both of those. Integral of 1. What did I take the derivative of to up with 1? Regular x. And then I'm going to add 1 to the power. Gives me 0. Multiplied by the reciprocal of the new power. I don't even know what to do with that. Oh yeah, that's not what we do for this one. We do natural logs. So this 5 just kind of hangs out. So if you have a 5 in front of an e or an ln or a cos or whatever constant you have, it just drops down. And then the integral of x to the negative 1 is the natural log of the absolute value of x. And then you throw a plus c on the ends because we don't know what's there, and they're not telling me to find a particular solution. So I'm good. Does that make sense what I'm doing? Other questions on? Alright. Yeah. So like separately, if I just gave you this, the way to think about what's happening is you're allowed to like take that 5 out. And then this will give you ln of x, right? So we're kind of doing that. We're just not like taking the 5 out. But that's the rule we're following. Try 4. Even Bowman didn't do the notes. I mean, probably no one else did. It's a good page. You get it. No, I didn't. So, be real with me. How many of you never watched it?
Yes.
Okay.
Sometimes I just forget. I do.
Do you think it's beneficial?
Sometimes.
You don't think so?
Well, I don't. I actually really don't like the notes because I feel like the way he explains it is completely different from the way you explain it. So then when like you get help from you, like
It's
it's
a
like
little different.
yeah, and then like the way like his stuff is all written is like different from how the tests are written. So I think that strategy is different than like the reviews and stuff.
I like them just because I like watching someone go through it, and then I don't really like paying attention that well to these videos because I know that you'll explain it better in class. So like just knowing what we're gonna learn the next day, it's like a little like debrief, and then I can think about it overnight. And then
So that I totally like. So let me ask you this: if I don't really require the videos, right? But if I just didn't, there's these videos and they're optional next year. How many of you would still watch the videos? Like they're optional.
But like if you just taught like this in class, I would still.
You would still do videos.
Yeah, because I like them. But like
Okay.
if it was like completely different, like there were
No,
different
like
worksheets.
I'm just kind of thinking for next year. I almost don't, because I just go through the notepad
Yeah.
every time. So like, do I really need to make students watch the video, or is it actually helping them? I'm asking you guys.
I like that they're there.
Okay, that's a fair answer. You like that they're there. If you're falling behind, if you're stuck, you're struggling, you can watch them.
Like if you miss class.
If you miss class, okay, you'd watch it like regardless, probably.
This is the first time I haven't watched it. I have no idea what's going on. So it's very nice to know what's going on.
Yeah, it's like a preview where you can kind of start your understanding.
Yeah, it's really nice.
Yeah. So try 4. Since nobody watches the freaking videos, try number 4. even what I've done so far.
Fine, but I'm starting to.
Yeah, yeah.
It feels
But you
way
feel better
different.
when you understand it. So the same students are gonna watch whether I'm mandating them or not. Plus it's not like I'm mandating them anyways. I fucking hungry.
Sit down on one.
I didn't see that coming. To be fair, it's not like you have any. Like, I just meant like.
I really don't.
No, there wasn't like a slam. I just meant like if someone that was, had it 100% was like, I don't like the videos. That carries a little more weight.
Right.
You know what I mean?
I had watched all the videos with my Randy better.
I don't know.
A favorite version of me had watched every
They were a
single
different timeline where you watched the videos.
Yes.
Then you what?
I don't watch the videos.
What did you say you don't watch the videos of what? Do you think that helped or no? So you're like not really paying attention. You're just like, okay. They're like 10 minutes.
Yeah.
So,
Yeah.
I just like writing
this
this down.
20 every single.
Oh, really?
This one is, yeah. This shit is hard though. Like, I feel like this is one of the most.
It's not. It's just,
It's
he
just
goes through it really fast. Like, he makes this, what, 2 sections, what I would have made like 5. So that's why we're doing like a couple days. We'll slow down and do.
Yeah, because like the going backwards is just so weird.
You get used to it.
Yeah,
So you just buy these books every year.
They're going to. They still do it.
I love this. This
The
is
books I
amazing.
think are really cool.
Yeah.
It's like super easy to review because you got everything right. Yeah, I love the books.
Yeah, and like when I'm on a test, I know exactly where one lesson is, so I just put 6.5.
That's cool. That's perfect. Okay. Okay, let's do this. So I got to integrate this because I got to go from F prime to F. So first of all, I would rewrite it. So let's make sure we understand why we're integrating first, right? So we have F prime. They're asking us about F. To go from F prime to F, we have to integrate to go up a level. I don't have like from 2 to 4 or something, so this is an indefinite integral. We're going to end up with a plus C, and then we're going to plug in X and Y to find out what C is. So when I integrate this, and you might start down this path, you might have recognized it by now, I don't know, but okay, I'm going to add 1 to the power, that gives me 0. Multiply by the reciprocal, but what's the reciprocal of 0? I don't know, it doesn't work. Oh yeah, that's because I'm supposed to use natural log. So that 2 just hangs out. Remember, it's like we factor it out. We integrate the x to the negative 1, and then we put the 2 back. So it's just like you undo it and put it back together. Here I can do the add 1 to the power thing. So I add 1 to that and get negative 1. Multiply by the reciprocal of negative 1, which is negative 1. So then 6 times negative 1 is negative 6. And then I've got my plus C and my equals Y. Questions there? So now I know x is 1 and y is negative 7. So 2 times the ln of 1, and I don't need the absolute value signs anymore because 1 is positive, so the absolute value is like redundant at this point. Minus 6 times 1 to the negative 1 plus c equals the y value, which is negative 7. Alright, natural log of 1. So remember, what that is there's really an e down here, and you're saying e to what power gives me 1? What power always gives me 1? 0 power always gives you 1. So this is 2 times 0. So this just goes away. That's 0. This is 1 to the negative 1 is raise 1 to the first, which is 1. And then flip it over. Still 1. And then multiply by 6. So negative 6. Plus c equals negative 7. What's up? Are we good? add 6, and I should get c equals -1. And then go back. This happens on the gateway too. That you'll get to here and you'll stop because you feel like you accomplished something, and you did, but like you didn't quite finish the deal. So you do have to go back and write down the original integral that we had, but replace the c with what we now know c is. But I will get a few students every year that if I gave this question, they would put this answer on the gateway, which is super frustrating because you knew how to do it. You got to where you were supposed to. You forgot like the easy part. Yeah. It doesn't matter to me. So on a multiple choice on the like AP or like if there's multiple choice on our unit test, you just gotta know they're the same because I can write it either way. But I don't care how you. How many had that? How many got to that? Questions I can help with? That definitely wasn't everybody. Did everybody get to hear and stuff? Thought you were cool. Thought you were done. Alright, well you get to practice more. I mean that's the point of the notes, right? Or the practice in the notes. Alright. Bad news is the next stuff is trig integrals. Good news is you guys get your notebooks, so you don't have to memorize. If you're taking the AP test, you obviously will not have your notebook. And in that case, you're going to want to memorize it. But for now, see if you can tell me. I think Zach was telling me this earlier to try to convince us to go to the play. What's the integral of cosine, Heike?
Cosine.
You're so close. If you got it right, we'd have gone, but too bad. So
Still learning, but I agree.
I said minus cosine.
so it does get weird because like the derivative of sine is cos, but the derivative of cos is negative sine. So like the sines are. So what's the derivative of sine? Cos. What's the integral of sine? Negative cos. So that little difference there between the plus and the minus can definitely be confusing. Integral of secant squared. What do we take the derivative of to end up with secant squared? Tangent. So that's tan of x plus c. What did we take the derivative of to end up with cosec cotangent? That's just the way. So when I gave you, it's not like any rule. It's just the definition. When I gave you tangent, the derivative was secant squared. And so when I integrate secant squared, so like we actually haven't integrated tangent yet because we don't know how yet. So you'll notice integral of tan is not on this list. This is just the 6 things we learned, but backwards. Because I can't integrate tangent. We will like next week sometime. So you got that to look forward to. It's a big day. What do we take the derivative of to get to cosecant cotangent? Negative something. Negative cosecant plus c. What about sectan? What did I take the derivative of to get to sectan? Secant of x plus c. And then like this squared, it's not like a special rule or anything. It's just again a definition that we had before. What did we start with if we took the derivative and ended up with positive cosecant squared? Negative cotangent. Good. Okay, so if I look at number 5, 3 times secant squared of x. So what's really happening is we're going to take the 3 out. We don't really need to do it, but just to like make sure you understand why you're allowed to drop that 3 down. Then let's integrate secant squared of x. So I know the integral of secant squared is tan of x. I put my plus c. And so I could have just like dropped 3 straight down the whole time. I don't necessarily need to factor it out and then put it there. But again, just trying to show you why that's okay. Like why that works. Questions there? 6 looks a little tougher. We got pi's and sine. Those are terrifying. So I got dy dx and I've got particular. And I got, which means derivative, right? And I got to go to f of x. So how do I go from dy dx to f of x? Integrate. So I'm going to integrate 1 minus sine of x. So what's the integral of 1? 1x. The the integral of negative sine, positive cos, good. So this will be x plus cosine of x plus c equals y. And then I know this is my x and this is my y. Plug in, so I get pi plus cosine of pi plus c equals pi minus 2. Well, these pi's, like let's say I subtract pi from both sides. Subtract pi from both sides, those just go away. And then what's cosine of pi? Pi is, so from your perspective, pi is over there. What's the x value? Yeah, that's the y value. -1. So -1 plus c equals -2. If I add 1 to both sides, c will be -1. So again, like I'm feeling pretty proud of myself because I got to that. But if I stop there, I'm not done. Make sure you go back to the original integral and replace the c with what we now know c is. Now I feel super proud of myself. Instead of just regular. Questions on that? What's we got here? What's up? Do you think this is like kind of hard?
Well, yeah.
Okay. No, it's fine. I want your feedback.
Yeah.
It's a
Well,
lot.
I was just saying, like normally, we're working on like the practice by like 11.
True. True.
Like just like a long lesson that he's gonna have to pick up on.
Yeah. We're gonna not worry about the inverse ones right now. We may not worry about them at all. They're like very rarely on the AP test. So for right now, we're gonna worry about them. We may come back to them. We may not. But I do definitely want to show you, especially this kind. This kind's no. Nine's harder, 10's easier. What should I do first? The hard one. Okay. So there is no quotient rule for integration. It just doesn't work. So we don't want fractions. We don't want quotients if we can avoid it. So we have to make this so it is not like one giant fraction. I showed you guys this with derivatives too, but let me just review it. Let's say I had like 5 plus 10 plus 15 over 10. Work that out. What is that? At the end, like after you simplify all that. It's not 2. It's 3. Sorry. I thought I was presenting an easy question. So that's like 30 over 10, right? Which is 3. Well, what if I did this? 5 tenths plus 10 tenths plus 15 tenths. What do those add up to? 0.5 plus 1 plus 1. Isn't it also 3? So my point is you are allowed to separate fractions like that. So if there's like, there could be 10 things divided by 1. You can make all of those individual things divided by the thing on the bottom. So I'm going to rewrite this as the integral of 3x squared over x plus x over x minus 2 over x. Which doesn't look simpler right now, but in a second I can make it look simpler. But that's the rule I'm trying to get you to understand with the 5, 10, 15 thing is you're allowed to do that. You can take that and divide it by the bottom, plus that and divide it by the bottom, plus that and divide it by the bottom, and it's still the same. So we can now simplify what's in here. So 3x squared divided by x is just 3x, right? X divided by x is 1. And then this, I'm just going to rewrite like 2x to the negative first. You guys okay? See what I'm doing? You definitely look less stressed out after you watch it.
Right, yeah.
Yeah. So
This is new territory.
this is This is just go with your rules. So add 1 to the power. multiply by the reciprocal of the new power. So take 1/2 and multiply it by 3. And that'd be 3 halves. Plus, what's the integral of 1? X. And then I could start down my add 1 to the power path right here, but I will get stuck because it ends up being 0. So the -2 factors out, and then we integrate x to the -1 by saying that's the natural log of the absolute value of x. We finally get to the plus. Students typically struggle with those. Like there will be one in the gateway, and it's very often like missed a lot on the first one, and then it kind of gets better on the next two. And I don't know how to explain it different or better, but if there's questions on it, please let me know. Like, I think most years right now, kids are like, "Oh yeah, that makes sense, it's fine," and then like tomorrow they'd be like, "I've never seen this before." So we'll just practice them. That's all we can do. Number 10. This is not that big a deal, but you can't. There's no like product rule for integration either, so you can't do it like this. So you just distribute. But distributing is we're a little more used to it. It's more obvious to most people. I would probably first write that like x to the 1/2 plus x squared on the inside, so I have like powers instead of the square root sign. And then multiply, and remember when you're multiplying, you're adding powers. There's really like a 1 there. So it's 3x to the 3/2 plus 3x to the 3rd times dx. And now it's in a form you can take the integral, because you just have like one term plus another term. You just use the regular power rule. Questions on what I'm doing? Yeah, I'm not done. So then integrate each thing one at a time by the power rule. So add 1 to the power here. We'll give you 5/2. Then you're going to multiply by 2/5. So you're multiplying 3 by 2/5, which is 6/5. Make sure you understand that. 2/5 times 3 is really 2/5 times 3 over 1, right? So you go straight across the top, straight across the bottom. I will every year see kids that are like, "Oh, I'm going to multiply the top and bottom by 3." Well, what'd you just multiply by if you did that? 1, so there's no point in doing it. So just be careful that if it's times a constant, you put a 1 on the bottom, not like the same thing on the bottom. Okay, so then I'm going on to my next one. Add 1 to the power is 4. Multiply by 1/4, and there's a 3 out there, so 3 times 1/4 is 3/4. And my plus. Question on that? Yes. You didn't say it again. You can, yeah. So if you factor out the 3, it's just like out here. And then when you multiply it back in, you should end up with the same thing. Yes, it is legal. Totally. So if it's like a 17 or something, absolutely factor it out, do all the rest, and then put it back because you want to work with 17. Other questions on that or anything I've gone through that I can help with? Is that it for the no one? All right, so I want you to do. We'll break it up a little bit. Actually, there's nothing really to break. That's actually a good idea. I'm sorry, I shouldn't say actually, like it's the first idea. You actually said something smart. Let's do evens. And then we'll check it over, I'll answer questions. I know. Oh yeah. It looks like a pot that's like tipped. Yeah. Someone called pot on the top. Oh, that's
Yeah.
it's thinking too hard, sorry. Yeah, that's good. Do evens, we'll check them, see where you get stuck. I'll go through whatever tomorrow. But
8 to 9 inches.
I read 1 to 3. Starting at, like,
It's more.
This is the typical forecast that has no idea what's going on. We take out
42.
I heard 27 to 36 inches. I mean, if we have a snow day, then I expect you to be here anyway. It's calculus. We do it regardless.
We don't get breaks.
We don't get breaks.